Hello everyone. So this is a question from JEE Advanced 2021 paper 2. For the following reaction, 2x plus y giving us P, the rate of the reaction is dP by dt is equal to K into the concentration of X. 2 moles of X are mixed with 1 mole of Y to make 1 liter of the solution. Okay. At 50 seconds, zero point 0.5 mole of Y is left in the reaction mixture. Okay, so ln2 value is given and there are a few options given to us, and the chapters involved is chemical kinetics. So here the important things are that this is the reaction that we are talking about, and this is given to us. Then we are starting with 2 moles of X and 1 mole of Y, also 1 liter of the solution. At 50 second we have zero point 0.5 mole of Y left. Okay, and there are 4 options. So one of them talks about the rate constant, then t half-life, then what happens at 50 second and what happens at 100 second. Okay, so to start with, consider the reaction 2 moles of N2O5 giving me 4 moles of NO2 and 1 mole of O2, right? So the rate of decomposition or disappearance of N2O5 will be, so rate of decomposition or disappearance of N2O5 will be minus, obviously because it is disappearing, d of concentration of N2O5 divided by dt. Okay. Similarly, the rate of formation of NO2, because it is the product. So rate of formation of NO2 will be equal to plus and d of concentration of NO2 divided by dt. Similarly, the rate of formation of O2, again it is one of the products. So that is going to be, you can also say rate of appearance of O2. So that is going to be plus d of O2 by concentration of O2 by dt, right? So these rates, the above rates, they are not equal to each other. That is, rate of decomposition of N2O5 is not equal to rate of formation of NO2, which is not equal to rate of formation of O2. This is very important. Is rate of decomposition of N2O5 is not equal to a rate of formation of NO2, that is not equal to rate of formation of O2. Okay, so the reason is because when 2 moles of N2O5 decomposes, at the same time 4 moles of NO2 and 1 mole of O2 is produced. So obviously their individual decomposition and formation rates are not equal. Okay, so therefore, to get identical value of rate of reaction in terms of any reactant or product, the rates expressed above, for example, the rate of formation of NO2 or the rate of decomposition or rate of formation, are divided by the stoichiometric coefficient. Very important. Okay, so to get identical value of rate of reaction in terms of any reactant or product, so rates expressed above, that is the rate of decomposition, the rate of formation, are divided by the stoichiometric coefficient. Okay, so therefore for the above reaction, that is for this particular reaction, we can write rate of reaction will be equal to, so the stoichiometric coefficient of N2O5 is 2, so we will divide it by 2. 1 by 2 into minus of d concentration of N2O5 by dt, which will be equal to plus, obviously, and um, since the molar coefficient is 4, okay, I'm talking about this reaction, 2N2O5 giving me 4NO2 plus O2, right? So it will be 1 by 4 into d of concentration of NO2 divided by dt, and which will be equal to plus, again, the molar coefficient of O2 is 1, so therefore it will be 1 into d of O2 by dt. Okay, so knowing this, now we can proceed. So our reaction in the question is 2x plus y is giving us p. Okay, so for this reaction we can write down the rate of the reaction will be, obviously, the molar coefficient of x is 2, so it is going to be minus 1 by 2 into d of concentration of x divided by dt, which will be equal to, again, the molar coefficient of y is 1, so it is going to be minus d into concentration of y by dt, and that will be equal to, in for p the molar coefficient is 1, stoichiometric coefficient, so therefore it is going to be plus d into p by dt. And also it is given to us that rate of reaction, that is plus dp by dt, is equal to k into concentration of x. This is given to us in the question. So therefore we can write minus 1 by 2 dx by dt will be equal to minus dy by dt will be equal to dp by dt, which will be ultimately equal to k into concentration of x, because we know that dp by dt itself is equal to minus dy by dt, which is equal to minus 1 by 2 dx by dt. So that's why finally we arrive here. Okay, cool. Now, also given that initially we have started with 2 moles of x, important information. Initially, we have 2 moles of x and 1 mole of y, and in a 1 liter solution. Okay, so we will write down the reaction. Our reaction is 2x plus y giving us p. So we will make a ICE table for this. ICE table is initial change and equilibrium table. So it is given to us that at time t equal to 0, the number of moles of x is 2, the number of moles of y is 1, and obviously the number of moles of p will be 0. Okay, so let's say this is the initial. Then, after some time, what will happen? Minus 2x minus x, and here we will be plus x. So this is known as the change. So this is the, so according to stoichiometry, how much amount has dissociated. So from 2 moles, after some time, 2x will be dissociated. From 1 mole of y, minus x will be dissociated. From 0 moles of p, plus x will be formed. Okay, so this is the amount that has dissociated for x after time t. This is the amount of y that has dissociated after time t for y. This is the amount that has formed after time t for p. And let's say that at time t equal to t, so how much will we be left with? Obviously, initially we had 2, and minus 2x has dissociated or decomposed. So we'll be left with 2 minus 2x. In the case of y, we started with 1. Minus x has dissociated. So we are left with 1 minus x. In the case of p, we started with 0, but plus x has formed. So how much p is remaining? That is x. So this is known as the equilibrium. Okay, so initial is at time t equal to 0. Change tells us, how much amount has dissociated. Equilibrium means how much is remaining. So that's the meaning of a ICE table. Okay, so this is what is remaining at time t equal to t. Okay, now it is given to us in the question that at time t equal to 50 seconds, 0.5 mole of y is left. Okay, so let's say that this time is equal to 50 So therefore 0.5 mole of y is left. So 1 minus x will be obviously equal to 0.5, right? Because we are assuming that the time t equal to t is 50. So 1 minus x will be equal to 0.5 as given in the question. So therefore we can write that at time t equal to 50, 1 minus x small x will be equal to 0.5. So therefore x will be equal to 0.5 or 1 by 2. Very important. Okay. So using these informations, now we can talk about our options one by one. Okay. So option A. In option A, we are supposed to find the rate constant of the reaction. Okay. So to find the rate constant of the reaction, we know that we have already found out, we know that minus 1 by 2 dx by dt will be equal to k into the concentration of x. Okay, so I will write that down. Minus 1 by 2 into dx by dt will be equal to k into concentration of x. Okay, one more thing, don't get confused with this capital X and with this small x. Okay, capital X is the concentration, it's x basically in this reaction, this x, and small x is how much has dissociated. So both are different. Okay, cool. So let's integrate. Let's say this is equation 1, so let's integrate this. So the limits of integration, let's keep them from time. One second, before integration we have to do certain things, that is bring x here and dt there. So it will become ultimately dx by concentration of x will be equal to minus 2k into dt. Now we can integrate them. Okay, so let's keep the limits of integration for time from 0 to 50. Okay, and concentration of x at 0. Okay, to find the limits in the LHS, so at time t equal to 0, the concentration of x was, remember, 2 moles divided by 1 liter, so it is 2 molar, so here it will be 2. And at time t equal to 50, concentration of x will be equal to, so remember, at time t equal to 50, the concentration of x is 2 minus 2x. Okay, so it is 2 minus 2x, and x, we found out that x is 1 by 2. Remember, this x is 1 by 2. So therefore it will be 2 minus 2 into 1 by 2. So therefore the concentration of x is 2. Sorry, 2 minus 1 is 1. So therefore it will be 1. So this is the limits of integration. At time t equal to 0, the concentration of x is 2. At time t equal to 50, the concentration of x is 1 molar. So therefore, doing this integration, we know that integration of 1 by x is ln x. So therefore, LHS will become ln x, and the limits of integration are 2 to 1, and RHS is minus 2k constant out. Integration of dt will be t, so it will be minus 2k into t, and limits are from 0 to 50. Okay, so so this becomes ln 1 minus ln 2 is equal to minus 2k into 50, and we know that ln 1 is 0. So therefore basically minus ln 2 is equal to minus 100k. So minus minus gone. So therefore k is equal to 0.693 divided by 100, or you can write 0.006931. Okay, so therefore option A is incorrect. Option A says that the rate constant of the reaction is 13.86 into 10 power minus 4. So therefore this is the actual rate constant. So therefore option A is incorrect. Okay, next going to option B. So option B talks about half-life of X. Okay, so half-life is the time required for the concentration of a reactant to become half of its initial value. Okay, important. T half is time required for the concentration of a reactant to become half of its initial value. Okay, so at time t equal to 0, remember the concentration of X will be, so we started with 2 moles of X and 1 liter of the solution, so concentration is 2 molar, right? And at time t equal to 50, remember the number of moles of X was, so to find out the number of moles of X at time t equal to 50, it is 2 minus 2x, and X is zero point 0.5 or 1 by 2. So therefore 2 minus 2x was 1, right? So the number of moles of X was 1 and the volume of the solution is 1 liter. So therefore concentration will be 1 molar, right? Cool. Now, can you see at t is equal to 50 second, concentration of X, that is 1 molar, became half of its initial concentration, that was 2 molar, right? At t equal to 50, 2 became half of its value, that is 1. So therefore t half of X is 50 second. And therefore statement B is correct. Okay, that is half life of X is 50 second. Half life of X is 50 second. Okay, let's talk about statement C. Okay, so statement C says that at 50 second minus dx by dt is 13.86 into 10 power minus 3. Okay, so to find out dx by dt, we have found a relation. If you remember, this was the relation that we found. Minus 1 by 2 dx by dt is equal to minus dy by dt, dp by dt, and k into concentration of X, right? So using this, we can write down that minus 1 by 2 dx by dt is equal to k into X, right? So they are asking us the value of minus dx by dt, this guy, at 50 second. At 50 second, concentration of X is 1 molar. We found it out, right? Because it's the T half. So X will be 1 molar, right? So therefore, we can write minus 1 by 2 dx by dt will be equal to k into 1. And we know that, so therefore we can write minus dx by dt will be equal to 2 into k, right? And we have found the value of k. K was, if you remember, 0.693 by 100, or we can also write that k is equal to ln 2 by 100, right? So 2 into ln 2 by 100. So when you do this calculation, you will get minus dx by dt at 50 second as 0.01386. You can also write this guy as 13.86 into 10 to the power minus 3. So therefore statement C is correct. Okay, this is a correct statement. Option C is correct. And coming to the final option says that at 100 second minus dy by dt is equal to 3.46 into 10 to the power minus 3. Okay, so it talks about minus dy by dt. So again, using the previous derivation, previous relation, this one, we know that minus 1 by 2 into dx by dt will be equal to minus dy by dt equal to k into concentration of X, right? Or we can say that minus dy by dt is equal to k into concentration of X, right? In the question, we are supposed to calculate this guy at 100 second. And to calculate minus dy by dt at 100 second, we have to know what is the concentration of X at 100 second. That is very important, okay? This at 100 second is very important. So we know few information. we know the reaction is 2x plus y giving us P. If you remember at time t equal to 0, we had 2 moles of x and volume of the solution 1 liter, so concentration is 2 and the concentration of y was 1. And at t equal to 50 second, which is the half-life of x, 2 will become 1, 2 became 1, right? Concentration reduced to half. At t equal to 100 second, which is the second half-life, t equal to 50 is the first half-life, t equal to 100 is the second half-life. So what will happen? At the first half-life, 2 became 1. At the second half-life, 1 will become its half, that is 1 by 2. So therefore, the concentration of x at t equal to 100 second is 1 by 2. So concentration of x at 100 is equal to 1 by 2. So therefore, now we can write that minus dy by dt is equal to k into 1 by 2. And k we already know that it is equal to ln 2 by 100. So ln 2 by 100 into 1 by 2. So ln 2 is 0.693 by 200. So when you do this calculation, you will get it as 0.00346, and which can be written as 3.46 into 10 to the power minus 3. So therefore C is also a correct option. Okay. So therefore A is incorrect, B is correct, C is also correct, and D is also correct.